Hello everyone. I'm just going to make a couple quick videos on radicals. I think most of you probably remember it from previous math classes. But what I have on the screen right now are what we call perfect squares. From these radicals, obviously when I take the square root, they are whole numbers. So for example, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and square root of 16 is 4, 5, 6, 7. And you should remember these. These numbers should kind of stand out to you. When we get down to 100, and then in the columns, square root of 121 is 11, 12, 169 is 13, 196, 14, 225 is 15. You don't have to memorize these at all, but they should kind of stand out to you, and they help breaking down regular radicals a little easier. So for example, if I come to the square root of 75, some of your teachers will absolutely try to have you find a perfect square. And so if you think of 75 and you try to think of our list, a lot of times the first number that would come to mind would be 25, and 75 divided by 25 would be 3. So some math teachers would have you make sure that you do the square root of 25 and the square root of 3, and then they would say to you, okay, what is the square root of 25? It's 5. So that comes out, but the square root of 3 stays in the radical. I kind of just teach it, break it down as a prime factor tree. So any factors you can think of. So even if you did 25 and 3, then I say go down to any prime number. So 5's prime, 3's prime. I can't cross out anything that I broke down. And then I say to myself, okay, since we're doing a square root, which technically there is a little 2 here that you don't really see, and the square root means to find pairs. So if I find a pair, the pair comes out in front, so that's saying that that is a perfect square somewhere in the factor tree. And then you get yourself a square root of 3 inside. Okay, so let's look at another. So if I look at 3, the square root of 90, I'm going to take 90 and I'm going to think of any factor. So right off my head, I get 9 and 10, and then I get 3 and 3, and then I get 5 and 2. And now I break down, I cross out, everything I have is prime. I find my pairs, my pair of 3's here. 5 and 2 do not have any pairs. So they're going to have to go back in a radical. When I put them back in the radical, they get multiplied together. So they are what is 10. 10 doesn't break down. And then the pair of 3's, which will now get to come out as a 3 because it's really the square root of 9. So a 3 comes out, but please remember we have the 3 out in front. So you would multiply them and your final answer would be 9, the square root of 10. Okay? So if you want on a scrap piece of paper or you want to do it on your desk with a marker and rag, why don't you try this one? Pause the video. So I'm going to do 6 and 10. You don't have to. You could do 3 and 2 and 2 and 5. Cross out. I now have a pair of 2's. If by chance you have 2 pairs, a pair of 2's and a pair of 5's, like you come across multiple pairs, then you multiply those numbers together. If you ever came out with a factor tree of like 2, 2, and 2, and a 5 here, you can only pair off, so they would be left behind. Sorry, so back to this. So back to this problem. So a pair of 2's would come out, but let's not forget the 4, so it would be 8, and then the 3 and the 5 would get multiplied together and be 15. So 8 root 15 would be that. And then the last one I'm going to look at is this. If you looked at this and realized right away that 225 is a perfect square, then you could obviously say this would become 3 times 15. But if you don't and you're not even thinking and you go to separate it, you might come up with that 225 and divided by 15 is 15 and 15. I just want to let you know at any time you come across a pair, you can stop and circle it because it's kind of silly to go 5 and 3, 5 and 3, and then say, okay, pair of 5's come out 5. Pair of 3's come out 3, back to 15. So if you come across a pair at any point, you could stop and circle that and say 15. 15 on the outside and 3 on the outside, so it's 15 times 3, and that's 45. Okay, that's it for breaking down radicals. On your worksheet, you could try 1 through 8 on your worksheet that I gave you.